Hi everyone, welcome back to my channel. In this video, we are going to learn how to determine and interpret instantaneous velocity of a particle from displacement function. Basically, when you are given a displacement function and the question asks you to find instantaneous velocity, we just have to do differentiation. But before that, let's check one example to learn more about the concept. Example A. A particle moves along a straight line. Its displacement is given by s equals to 40t minus 5t squared, such that t is in between 0 and 10. So we can draw a displacement time graph and see whether we can identify the answer for velocity based on the graph. First of all, we have a displacement time graph based on this equation, s equals to 40t minus 5t squared. The gradient of tangent of all the points on the curve is actually instantaneous velocity. That means if you have a point here and if you want to draw a tangent line, the gradient of the tangent line is ds dt. And ds dt is actually velocity. So that means the gradient of tangent of the point here is called instantaneous velocity. And since this displacement time graph is in the shape of a parabola, that means the instantaneous velocity at every point here will be different. Okay, next, let's check. At t equals to 0, if you want to get the answer of velocity, you see this is the displacement equation. So if I want to identify velocity, I have to do differentiation. So differentiate 40t, answer 40. Differentiate negative 5t squared, answer negative 10t. To find the initial velocity, I sub t equals to 0 into this equation. I have v equals to 40. That means the initial velocity is 40. This is displacement time graph. 0, 0 here means when t equals to 0, s equals to 0. But if for the 0, 0 point, I want to draw a tangent line, you see the tangent line slants to the right. Okay, that means ds dt is greater than 0. Okay, v greater than 0. That's why we have answer v equals to 40. Okay, next one. When t equals to 4, we have maximum displacement. So for this equation, 40t minus 5t squared, this is a quadratic equation with a equals to negative 5, means less than 0. That means you will have a maximum point. And in this case, the maximum point occurs when t equals to 4. Okay, when you have a maximum displacement, let's check for this point. If I want to draw a tangent line, the tangent line is a horizontal line. That means differentiation answer is 0. ds dt is 0 and ds dt is v. So v equals to 0. That means when you have a maximum displacement, v is actually 0. Instantaneous velocity is 0. Okay, then generally, if you have a maximum or minimum displacement, we have gradient of tangent 0 and also instantaneous velocity 0. Next, let's check another case. Let's say we have another displacement function here, s equals to 5t. So we notice that s power 1 and t is also power 1. So if the question requires you to draw a graph, you know you have to draw a linear graph. So we have a linear displacement time graph like this. And for this kind of graph, the gradient of tangent at any point is the same. That means, let's say I have a point here and a point here. If I want to draw a tangent line for both of them, I notice that the gradient of tangent for both of the points will be the same. And gradient of tangent for displacement function is ds dt. And ds dt is actually v. That means the instantaneous velocity for every point here is the same. That means we say that the instantaneous velocity is uniform, or you also can say that they have a constant velocity. Let's try example 16. The displacement of a particle is given by s equals to t power 3 minus 9t squared plus 24t plus 5. Calculate the initial velocity of the particle. So we are given a displacement function, but they ask us about velocity. So first of all, you have to know that we need to do differentiation to get velocity function. So differentiate t power 3, we have 3t squared. Differentiate negative 9t squared, we have negative 18t. Differentiate 24t, we have 24. Differentiate number, answer 0. Okay, initial velocity. Whenever we see the word initial, means t equals to 0. So we substitute t equals to 0 into the velocity function. Then we will have answer v equals to 24 meter per second. Okay, next B. Calculate the instantaneous velocity at 3 seconds. That means what's the answer for V when t equals to 3? So this is your velocity function. We just have to substitute t equals to 3 inside. Then we have answer V equals to negative 3. Okay, next one, C. The values of t in seconds when the particle is instantaneously at rest. When the particle is at rest means V equals to 0. So this is your answer for V. We let it be 0. Okay, 3t squared minus 18t plus 24 equals to 0. Please write down this step first, then only you simplify. Okay, so sometimes we have 1 mark here, and then we do division. I divide all the terms by 3, and then we do differentiation. Then we have 2 answers for t. T equals to positive 2 and positive 4. So both are accepted because both are positive. Okay, Donkey, the range of t in seconds when the particle moves to the left. Particle moves to the left means v less than 0. So this is your answer for V. 3t squared minus 18t plus 24 less than 0. Write down this step first, then only we do division. Divide every term by 3, and then we do factorization. So same thing, this is a quadratic inequality. So before you can get the range, you have to do either graph sketching method or number line method. So this is graph sketching method. We have the t-intercept 2 and 4. Less than 0. Less than 0 means y less than 0. Y coordinate less than 0. So for any graph, when the y coordinate is less than 0, the graph will be below the x-axis. That's why we choose the region that is below x-axis, which means t is in between 2 to 4. Example 17. A particle moves along a straight line. The displacement of the particle is given by s equals to 2t power 3 minus 5t squared plus 4t. Find the instantaneous velocity of the particle when t equals to 2. So from displacement function, when we want to get velocity function, we do differentiation. So differentiate 2t power 3, we have 6t squared. Differentiate negative 5t squared, we have negative 10t. Differentiate 4t, answer 4. When t equals to 2, so we substitute t equals to 2 into the velocity function. Then we have answer, instantaneous velocity is 8 meters per second. Okay, B, find the values of t when the particle stops instantaneously. When the particle stops, means v is equals to 0. So we copy down our velocity function, 6t squared minus 10t plus 4 equals to 0. Then only we do division. So I divide every term by 2. So we have 3t squared minus 5t plus 2 equals to 0. Then we do factorization. 3t minus 2t minus 1 equals to 0. Then we have 2 answers for t. T equals to 2 over 3 and t equals to 1. Both are positive, so both are accepted. Next one, C. Find the range of values of t in seconds when the particle moves to the right. When the particle moves to the right means v is greater than 0. So we copy down our velocity function, 6t squared minus 10t plus 4 greater than 0. Then I divide every term by 2. We have 3t squared minus 5t plus 2 greater than 0. Then we do factorization. So this is a quadratic inequality. So if you want to get the range of values of t, you have to firstly do either graph sketching method or number line method. So I do graph sketching method here. The t-intercept are 2 over 3 and 1. And then we check greater than 0, greater than 0. For every point with y coordinate greater than 0, we plot the point above the x-axis. So that's why when we see greater than 0, we will choose the graph that is above the x-axis. So that's why we choose these two regions. Okay, we read the region, t is less than 2/3 and t is greater than 1. And we have to be careful here whenever we see t is less than a number. Okay, because t cannot be negative. So for this answer, you have to write one more line. T is in between 0 and 2/3. T can be 0. So we have an equal sign here, but there's no equal sign here. Okay, or t is greater than 1.